All right, let's try some exercises now from Chapter 9, Section D1. Again, this is from the practice exercises. I'll just start with the first one. Starts off with a universal statement for all x. If kx, then not mx. And then line 2 says there exists an x such that kx and lx. And it's supposed to prove that there exists an x such that not mx. Not mx. Okay? So I look over here again, I see the main thing I want to look at here is this predicate m, right? Not mx. I want to see if I see anything like that in the premises, and I do. I see it in premise 1. It comes in the consequent of a conditional, so I start thinking that I'm going to use modus ponens at some point. To use modus ponens, I would need to work with that antecedent there, and I see something like that antecedent right here, right? So it looks like I'm going to be set up for a modus ponens if I can just get everything in the right, rewritten in the right form. So again, as sort of very typical with these predicate logic proofs, I don't really, besides change of quantifier, that kind of thing, I can't really do a lot with a quantified statement as it is. I want to be able to usually use the rules from chapter 8. And to be able to use the rules from chapter 8, I need to get rid of these quantifiers. So usually, again, the pretty standard procedure in a lot of these proofs is to instantiate the quantified statements to get rid of those quantifiers, and then if I need to get back to a quantified statement, I'll use a generalization at the end, in this case, existential generalization. So I want to be able to instantiate here, and I can see the pattern I want to do. I want to be able to instantiate so I can say that basically that k is true of some constant. I'll be able to drop off the Lx through simplification. So I'll instantiate this existential statement. I'll insert a constant. Again, you can use whatever letter you like, A, B, C. I'll go with A just because, why not? So I'll need to instantiate this, get Ka and La, and then I can simplify down to Ka, and then I should be able to instantiate this. Since this applies to everything, it'll also apply to A, and I'll be able to use modus ponens then. And then I'll just do an existential generalization to get from A to there exists an X. So that's the idea. Now just again be careful here. When I instantiate, you need to go in a particular order. If you instantiate the universal statement first, you're going to have a problem because you'll just pick, this applies to everything. So you'll pick one of those everythings, call it B, right? And you would write it down. And the problem you're going to have is when you instantiate this, you're not entitled to assume that it applies to B. It applies to something, but you're not entitled to assume it applies to B. So the way you have to do it is you first instantiate the existential statement. So you get K, A, and LA, right, from line 2, existential instantiation. Then it doesn't really matter which, what thing I picked, what label I gave this thing right here, because this applies to everything. So since the universal statement applies to everything, it's guaranteed to apply to whatever it is, whatever thing you just picked out here. So now I can say if Ka, then Ma. Oh, sorry, not Ma. Right? That is from line 1 by universal instantiation. Now I just simplify 3. Ka, right? From line 3 simplification. Right? And now that I have that, I can do my modus ponens and get not Ma. That is from lines 4 and 5. Modus ponens. So you can see that. And now I do my generalization. Now that I have not Ma, M is not true of A, I can say there exists something, it does exist something such that not mx. From line 6, existential generalization. And again, it's that familiar pattern. So once I sort of saw that I was going to be using modus ponens here, then it was just a simple matter of instantiating, doing my modus ponens, and then generalizing again. I just had to remember to be careful the order I went in for the reasons I explained. So hopefully that helps. I'll move on to another one.